Hi there, thanks for joining us. This is Space Nuts. My name is Andrew Dunkley, and it's always good to have your company. I hope you're well. Coming up on this episode, we will be discussing these things. A Sydney PhD student has created cosmic dust in a jar. Probably not quite a jar, but pretty close to a jar. So how did they do it, and what does this mean? Does it mean we'll never have to go out to space again? Possibly. Anyway, that's a really good story. This one, because I'm a bit of a volcano junkie, simultaneous volcanic eruptions have been recorded on Io, one of Jupiter's moons, and it's a very rare event. In fact, I think it's the first time it's been recorded as far as I'm aware. So we'll look at that. And here's a line for the ages: find the coal and we find the people. That's all coming up in this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And here to unravel the ravelment that is all of those stories is Professor Fred Watson, astronomer at large. Hello, Fred.
Hi, Andrew. I can easily ravel them all up again. I can tell you, make them even more raveled than they were to start with.
Yes, well, we don't strive for excellence here. We never have. It's all about adequacy.
Yeah,
haven't used that time for a while.
Sometimes we don't even make adequacy.
No, probably not. No, but there's some quirky stories today, and I'm very excited about this first one because I joked about us not having to go back into space and intercept asteroids and collect junk from them, because this kind of does it for us, and you don't have to leave the planet. The Sydney PhD student creating cosmic dust. This is quite extraordinary.
It is. It's actually a great story, and it's nice that it's got, it's got a local flavour to it because of the Sydney University connection. I used to have an honorary professorship at Sydney University, but I think it's lapsed now. I think they've got rid of me. So never mind. I'm still
like dishonouring a cheque.
Yeah, still happy to sing their praises. Sydney University is pretty good, particularly astrophysics.
Yeah, my dad went there.
Yeah. That's good. Anyway, what's it all about? It's about a bit of a mystery, because we now know that, a lot of the complex organic molecules that we often talk about as the building blocks of life, the amino acids and all of those sorts of things, we know that they are found in space. But what's not been clear is, two things not clear. One is, did they find their way to Earth? And maybe, when we find these chemicals in, for example, in meteors and in comets, maybe, yes, there have been collisions that have brought them to Earth. So that's a fairly logical step. But the big question has been, how do they form in the depths of space in enough quantities that they're quite commonplace? And we know they are, because we can see a lot of these basically these chemicals deep in the dust and gas clouds that we often analyse. Things like the nebulae, which have got not just gas in them, glowing gas, but often clouds of dust as well. And dust is very well studied by astronomers using infrared and radio telescopes. In fact, one of my close friends, who was one of my fellow students hundreds of years ago at St Andrews, made his career in studying cosmic dust and the contents of that, and looking at the way these chemicals come together or have been brought together. The question is, how do they come together? And that's the question that's been asked by a team at Sydney University, including the PhD candidate, who's, I think she might be the lead author on this paper, Linda Losurdo. She has essentially created this synthetic version of the cosmic dust that our infrared and radio astronomy colleagues measure in clouds of gas and dust. She's created it. She synthesized it in the laboratory, probably, as you said, in a jar, with other things as well. And the extraordinary thing is that what she's created seems to match what these carbonaceous dust particles tell us in space. In other words, it seems like a very accurate synthesis. So what she did was took a set of gases, quite simple, nitrogen, carbon dioxide and acetylene, which also contains hydrogen, oxygen, these gases in a tube, and then basically irradiated them with very intense electrical energy. They put 10,000 volts into the tube, which was almost in a vacuum, so the pressures are very low. And you actually, if you do that, you get these glow discharge phenomena. You get colours appearing from the excitation of the atoms. But what she also found was that on silicon, basically, silicate fingers within the tube, they found these tiny particles of dust forming. And when they analyze them, they've got exactly the same chemical signature as these dust clouds in space.
Wow.
And so what they're saying is that these basically these chemicals do form in the kind of high energy environment that you find around, for example, a white dwarf star that's beaming out ultraviolet radiation, or in the aftermath of a supernova, where you've got a sort of neutron star, which is also got high energy processes, because the supernova explosion itself creates shock waves and things of that sort. So she's basically mimicking those conditions and finding that what she gets in the jar is what you get in space when you see those conditions. So it's a really nice piece of work, and congratulations to them.
Yes, indeed. And I mean, I was probably being a bit silly, suggesting that this is going to replace the need to go out and catch asteroids and have a scratch around on the surface. We still need to do that because they're not all identical. There's going to be things to learn from various missions in the future, which we've already seen come to fruition in a couple of cases. But I suppose what she's done is she's opened the door to learning how things happen way out in space where we can't even get, and maybe coming up with ways of looking at these mysteries at a local level and kind of putting a bit more light on them, I suppose.
Yeah, that's right, to study them better. And, I'm sure this is just the beginning of a series of experiments that will produce some really interesting results, maybe even give us molecules that are actually closer to life molecules than they've already found. So I think it's a very promising avenue of research. Yeah,
it sort of coincides with a story I read last week that had nothing to do with astronomy or space dust, but it was a science story about a bloke who went to a river and took a handful of mud, shoved it in a jar, and then sealed it off from the rest of the world. And he filled it with water and just put it to one side, and he left it, and he covered it up, and he didn't go back for a couple of months, I think it was. And when he came back, it had created its own balanced ecosystem, completely separate from the rest of the world. New life had come and gone, and a species had become dominant, some kind of slug. It really does make you wonder how life hasn't been found anywhere else yet. If that can be done with a blob of mud from a river in a sealed jar. I mean, if you opened it, it all dies because they've created their own world. But it was an amazing story. I was captivated by it. That I didn't think it was possible. I thought if you cut off the outside world, that would be the end of it. But no, they created their own ecosystem and their own environment and their own atmosphere. And Yeah, it worked. I didn't think it was possible. Now kids are going to be going out, filling jars with mud and sealing them up.
Yeah,
It's
see what comes out of
a
it.
fascinating experiment.
Yeah, if you wait a few million years, your jar might, evolve a dinosaur or something like that.
Well, it could,
Small one.
a miniature one. You never know. That's a fascinating story. And this one is too, and you can read about it at phys.org. And I think the paper was published in the, I've lost it. There you go. I saw it there a minute ago, but there was a paper published, the Astrophysical Journal. There you are. So look out for that one. This is Space Nuts with Andrew Dunkley and Professor Fred Watson. Let's take a break from the show to tell you about our sponsor, Incogni. Now, if you've been overwhelmed by a barrage of spam calls and emails and targeted ads, robocalls, it's probably because they can find you online very, very easily and just harvest your contact information. If you've ever felt like that, then the answer is Incogni. What happens is data brokers collect and sell your details, leading to an endless array of spam and other potential risks. And if you want to get rid of that, Incogni is the answer. It's your personal data removal assistant. It automatically sends removal requests to over 210 data brokers, ensuring your information is taken down. You can even watch the progress of it through an online dashboard. With weekly updates, you can track the cleansing of your digital footprint. Plus, there's a 30-day money-back guarantee, so it's risk-free. It's called Incogni. Take control of your online presence. Visit incogni.com/spacenuts. And here's the kicker. 60% off if you use the code word spacenuts. That's incogni.com/spacenuts. 60% off if you use the code word spacenuts. Enjoy a peaceful online existence without digital disturbance.
Houston, Tranquility Base here. The Eagle has landed.
Space Nuts.
Now, this next story is just as fascinating. I guess most people will have heard of the moon Io, which orbits Jupiter. It's a very, very interesting and somewhat foreboding place. It's just absolutely covered in volcanoes, and they erupt quite a lot. But what's happened in this case is they have had 5 volcanoes erupt simultaneously, which has kind of got them wondering what's going on inside.
Exactly. That's right. In fact, that's the story in a nutshell. So, yes, Io, the innermost of the large moons of Jupiter, the ones that were discovered by Galileo back in 1610, it's the nearest one to the planet, and that means it feels the strongest and most disruptive, if I can put it that way, gravitational pull from Jupiter. So it's constantly being squashed and squeezed by the gravitation of Jupiter. And that's what we think is the reason behind its very active and dynamic volcanism. It is the most volcanically active body in the solar system. It's not the one covered with the most volcanoes. That's actually Venus. But Venus may be inactive now. We don't actually know whether Venus's volcanoes are still active. You and I have talked about that before. But we definitely know that the ones on Io are, because we've seen them on many occasions. And the results that have brought this story to the science media have come from our old friend Juno, the spacecraft, the orbiting spacecraft, a NASA spacecraft which is in orbit around Jupiter, and it's captured basically infrared images of the southern polar region of Io, and has realized that there are 5 volcanoes going off at the same time. So it is really quite an extraordinary thing, quite a coincidence. These volcanoes, they're all in the south polar region of Io, Io is about the same size as our moon. It's not a small world. So what they've done is tried to work out what that means if you've got, first of all, a very violent eruption. That was what drew their attention to this event. But the fact that nearby there were others in sync with the main volcano. So what I think is coming out of this is the suggestion of a porous or spongy interior for Io rather than a solid body as was thought before. And that might mean that there's some sort of almost like a liquid magma reservoir that's actually big enough that it pokes through the crust of Io in a number of different places. And so you've got several volcanoes all erupting simultaneously, what they call interconnected magma chambers, which would allow for these highly lava-rich eruptions to take place simultaneously. And so it sort of calls into question the old idea about the interior of Io, which was thought to be fairly solid. But if it's kind of porous and spongy, then that might explain why we're seeing these phenomena of such volcanic activity.
Yeah, and it's not the same kind of activity as we see on Earth with our volcanic eruptions, which is, to go to Io, it's being really squashed by the gravitational pull of Jupiter, isn't it? Is that what's mainly, like you squeeze the sponge and all the stuff comes out? Is that what's happening?
Well, yes, it's almost like that. That's right. You're right. As I said, it's the gravitational squashing and squeezing that being so close to Jupiter provides, what we call tidal forces, the tidal effect. So, yes, and, it's as though all the volcanoes in the Mediterranean, for example, suddenly started erupting at once. Vesuvius and the other ones that are in that region.
Stromboli.
Stromboli, yes. Yeah, Etna, that's right. That's the one I was thinking of. All of those, if they all suddenly started spewing out stuff at once, that would suggest something going on as we've got apparently on Io. But Io is a very different world from the Earth. And part of the reason for that is this external gravitational stress that comes from Jupiter.
Yeah, it's a very toxic world, isn't it? It's not a nice place. You wouldn't want to wander around on it.
No. Well, it's mostly sulfur, sulfur deposits that have come from these volcanoes. Yeah.
Wow.
Yeah, it's it actually is that's a nice thought experiment, just to imagine what it would be like wandering around on Io. I think it might be quite an interesting experience.
Wouldn't smell very nice.
No, neither would you probably after you
not
tramped over the volcanoes and the lava lakes. It's got lava lakes, big pools of lava that we know about too. So yes, an extraordinary world.
Yeah, it's got over 400 active volcanoes, apparently.
Yeah, that's right.
That's amazing. Now, you said it was about the same size as the moon. Here's another thought experiment. If you were to swap the moon and Io, if you could just somehow, put one where the other is and vice versa, what would happen to Io orbiting Earth and what would happen to the moon orbiting Jupiter?
I think the moon would turn into Io and Io would turn into the moon.
There you are.
Because they, yes, there might be compositional differences and things of that sort, but it really is the environment that dictates why Io is so volcanically active. And the moon, of course, in a much, much more benign environment. It's, in fact, we do see evidence of large-scale volcanism on the moon. That's where the Maria came from, the what so-called seas on the near side of the moon, these darker areas. They are the result of basalt flows, of lava flows. But that is from a period a long, long time ago. And the heat was probably driven more by impacts, by bombardment. This is during the late heavy bombardment when a lot of stuff was hitting the moon. and the Earth too, but Earth, of course, has plate tectonics, so the evidence for all that's gone, whereas it's still around on the moon. But since that period, 3.5, 4 billion years ago, things have been pretty quiet on the moon. But if you put it where Io is now, I'm sure it would turn into another Io.
I wondered, and that is interesting because we're pretty glad it won't happen. But then again, if you did swap them, it would make Artemis 2 a really interesting mission.
It certainly would. Yeah, it would. Imagine having to pick your way between the volcanoes before you land your SpaceX Starship on the moon.
Absolutely. And I also read that part of that gravitational tug of war that causes the volcanism on Io is also attributable to Europa and Ganymede. Apparently they have a part to play in it as well. So poor old Io is getting, bounced around like a ping pong ball, which is messy, as it turns out. Yeah.
Yeah. You won't want to play ping pong with it, though.
No, definitely not. It would definitely pong. For certain.
I wish I could say I fed you that line, but I'm afraid I didn't.
Yes. Oh, well, that's how it goes. If you would like to read up on that story, it's on the Daily Galaxy website, and I'm sure you'll be able to find a paper about it somewhere as well, because I forgot to look. I usually look these things up, and some people do like to read the papers, but I didn't do it in this case. And I'm doing what's called padding right now so that I can actually find where the paper's been published and then tell you, because you'll think I'm amazing, but no, I've got no idea. Yes, I have. It's been published in JGR Planet.
Try to get that in.
That's an old radio trick, that is, when where there's something you need to say and you haven't quite got your finger on the button, but you just patter away until you find it.
It's that you patter away, but you're doing that then on autopilot, and you're never quite sure what's going to come out.
No, that's true. Yeah, that's very true. But it is available, the paper, at JGR Planets. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson.
Hey, that's one of the better sims, believe me. We've had a couple of cardiac arrests down here too, Pete. There wasn't any time for that up here.
Space Nuts.
Our final story, Fred, is a really good one as well, and I love the way they've sort of spun this one. We've talked before about the search for extraterrestrial life and whether or not there are intelligent, communication-capable beings somewhere else in the universe. This new study or theory or whatever you want to call it, that's been published in the International Journal of Astrobiology, by the way, is basically saying that if we can find the coal, we will find the people. They've got a really interesting theory, and I think it probably does have some street cred.
Yeah, that's right. The normal mantra we talk about is follow the water, but in this case, it's follow the coal. And the difference is that following the water, we hope, will lead us to living organisms, whereas following the coal might lead you to ET. And all this article is saying really is that we, as an intelligent species, and with a fairly high degree of technology, which you and I are using right now, that has only come about because of the coal reserves that we find on the planet. And what that, and the reason for that is that the coal basically fueled the Industrial Revolution in North America, the UK, and Europe. That was, in fact, the world I grew up in, Andrew, was still fueled by coal. It was a very coal-dependent environment that I lived in. You've got to have coal in order to gain enough heat to be able to forge steel. Then your steel needs to be honed and treated in such a way that you can actually keep going and finding more fossil fuel, like oil, for example, with drill bits. So all of that stuff they say, comes actually from the fact that there were coal deposits not too far from the surface of the planet at just the time that we as a species were emerging and recognizing the possibilities of the Industrial Revolution, although it wasn't called that then. And in fact, here's a quote, and I'm quoting here again from phys.org. Without access to coal, our own civilization would never have been able to harness deep deposits of oil and gas and in turn generate enough heat and electricity to melt steel. This enabled the development of radio telescopes that today dot our own planet, which can send and receive messages across interstellar space. So what they're saying is they're linking our technological prowess to this sort of accident almost that we had these coal beds laid down 70 or so million years ago that are kind of just at the right time for us to, or were at the right time for them to have turned into coal and for that coal to be available near the surface so that we as a species could actually mine it and basically make use of it. What the authors of this article say is that if humans or something like humans had evolved earlier than we did, then coal might not have existed. It might not have, got from basically the peat that formed coal into the material that we can now mine. And so that suggests that once again, there is, it's almost like good bits of good luck that lead to our evolution as an intelligent species. Yeah. And what in turn that suggests is that once again, other intelligent species out there who are technologically able may actually be very rare if they're there at all.
If the circumstances that they're pointing to are required for an intelligent species to be able to communicate, which is one of the Drake equation
that's right.
parameters, that could mean that the number of intelligent species is probably even less than we would consider or hope. Yeah. And that's a bit sobering, a bit sad in many respects.
Well, that's right. There's so many aspects of the Drake equation. We only, the only, firm part of the Drake equation that we know about is that stars do form planets. Planets are very common, which was not known, when Frank Drake put that equation together. But yes, the number of civilizations that do go on to develop the technology to communicate, that is one of the terms in the equation. And if you don't have coal, you might never get there.
Yeah. Does that mean, though, that there may be intelligent species roaming planets somewhere else in the universe, but because they haven't been able to do what we've done because they don't have access to, say, coal, they reach a point where they can't go any further. So they're wandering around in their jockeys, knocking dinosaurs on the head or whatever they do, and that's as good as it gets. Is that
permanently in the Stone Age? Yes, yeah, I think that is. Yep.
Wow. Until a coal comet lands on the planet.
Well, that's right. Dump all the coal for
or a Coke asteroid
bottle.
Or that. Yeah. Wasn't there a movie about that once?
Well, I'd be surprised.
An African native who got hit on the head by a Coke bottle and decided to return it to the gods. That's a very funny film. Yes. But yes, find the coal and we might find the people. It does seem to have a bit of credibility, that particular theory, and you can read all about it at phys.org. It's also been published in the International Journal of Astrobiology. It's a fascinating story. And it does suggest that there might be intelligent species out there that can't communicate ever because they don't have the tools, because they can't make them. So that is fascinating indeed. We're just about done, Fred. Thank you very much. A nice quick one today.
It was certainly nice and also quick. Yes, you're right. I've just looked at the time. We'll chat again soon, I hope. What's your name again? Andrew, that's right.
It's definitely not Fred.
No, you were going to be James there for me, and that's my son, so I don't quite know what was going on there.
I know Fred's already taken, so I can't have that one. All right, we'll catch you next time. Thanks, Fred.
Yeah. See you later, Dave.
I get that one a lot. Professor Fred Watson, astronomer at large, joining us here on Space Nuts. Don't forget to visit us online as well at our website, spacenutspodcast.com or spacenuts.io, where you can send us questions or comments through the Ask Me Anything link at the top of the page. There's the daily news feed you can subscribe to. You can also go to our shop and have a bit of a browse around there. Lots of goodies in there. And if you want to find out how to support us, hit the support our podcast button and learn more about that. It's not mandatory, it's voluntary, and we do say thank you to the patrons that sign up. We really do appreciate your support. And thanks to Hugh in the studio, who couldn't be with us today because he's gone looking for coal. He thinks it's going to help him have better communications with his wife. And from me, Andrew Dunkley, thanks for your company. We'll see you on the next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.